All right, so if you're still trying to get on Desmos, that's okay. It should automatically pop for you guys. Anyway, today is all about, yes. So guys, I'm talking about the Desmos calculator. Should have automatically popped for you guys. Riley, try now. Caroline, try it now. All right. Is everyone on Desmos? All right. So like I said, today we're talking about a brand new function type, which is quadratic functions. So completely different than linear functions and exponential, which were the only two that we have been dealing with. So looking at the top of our journal, your I can statement for this lesson is I can identify key features of quadratic functions from its graph form, standard form, and factored form. So most of this lesson is your ability to read a graph and identify specific things that are going on. All right. Now, all the forms of this quadratics you've seen before except for the graph. All right. You have technically seen standard form before and the factored form of a quadratic because you saw it in the last unit. You just didn't know that's what it was. A quadratic function is technically a polynomial. All right, and a lot of the functions that we did factor in the last unit were quadratic functions. All right, so before we even talk about key features, we need to actually look at what is a quadratic. So open up that first tab. So a quadratic function is a non-linear function. So it's not the same thing as a linear function, not even in the same realm. And the degree of it, or the highest exponent, is 2. So remember, degree means its highest exponent. We learned that in the last unit. That exponent is 2, meaning that there's an x squared somewhere in there. Now, there are 2 ways in this class that you'll be seeing a quadratic equation. You'll either be seeing it in the first form, which is this one. So y equals ax squared plus bx plus c. That look familiar to you guys? So does that look familiar to you guys? We saw that last unit. This is considered its standard form of a quadratic. This might be. Hello?
At the very least, if you're in vertex, if you can move on, you can. You should be delta max too. 8.1 something. In fact, right now I assigned it to you guys.
So that's the standard form of a quadratic. It can also be written in the form y equals a times x minus r1 times x minus r2. Now, it looks a little funky, but that's actually what we've been dealing with a lot in the last unit, which was a factored form of a quadratic. So remember how I said you got to get really decent at factoring? That's why. You will see it again in this unit. Now, the shape of a quadratic graph looks something like a U shape, and these are called parabolas. So if you hear me throw the word parabola around a lot, I'm referring to the graph of a quadratic. So in this class, you're specifically looking at its graph form, its standard form, and its factored form. When you move on to Math 2, there's another form of a quadratic called vertex form, but we don't learn that in this class. We only care about standard and factored form. All right. Now, below are a couple of examples of quadratic graphs. All right. So these 3 pictures right here are examples of quadratic graphs. So as you can see, they do look like a U in shape, except for this last one. This is still considered a quadratic graph. All right. It's just upside down. And there's a reason for why it is, but we'll learn that later. Another thing to note is that this quadratic right here, so the first one on the far left, this is considered its parent form or its parent function. So when you get to Math 2 and Math 3, you're going to learn about something called parent functions. It means that that's its kind of base form. Every quadratic stems from this form, y equals x squared. Whether you add or subtract some extra stuff, that's kind of what determines where the graph goes, but most quadratics start from, actually all quadratics start from that form. So there's nothing you would really do with that right now. It's just good to know for like Math 2, if they ask you what a parent function is, that's the quadratic parent function. So now knowing what the graphs look like, we're going to look at some different key features. So we're going to start with the ones that you guys should already know about. All right. So let's look at x and y intercepts. So that's the next tab. Now, you guys should already know what x-intercepts and y-intercepts are. You dealt with them with linear functions. You've dealt with them with exponential. All right. Who remembers what defines an x-intercept? So what's an x-intercept? Guys, it's on the board. Come on. It's where the graph crosses the x-axis. What about a y-intercept? It's where it crosses the y-axis. All right. Now, when we were dealing with x and y intercepts, really we were only dealing, especially with x-intercepts, with all the different functions that we've talked about so far, it was always just one. All right. There was always one x-intercept, one y-intercept. With quadratic functions, that's not always true. So notice how when it says x-intercepts, there's a parentheses s on the end. That's because a quadratic function can have either 0, 1, or 2 x-intercepts, depending on its graph. So it can have up to 2 x-intercepts. It could also have no x-intercepts. It can have 1 x-intercept. Now, some other names for x-intercepts that you will hear a lot, so it's a good idea to note them down, is zeros, roots, and solutions. So just know that those three words are interchangeable with x-intercepts. So if I ever ask you to find the zero of a quadratic function, you're going to find the x-intercepts. If I ask you to find the solution of a quadratic function, x-intercepts. The roots, x-intercepts. All right, and you will see those three words a lot, not just in this class, but in Math 2 and Math 3. Now, to find the x-intercepts using just the function and not the graph, we can use its factored form. So if you were not given a graph, say it was the EOC, it was the calculator and active section, they ask you to find the x-intercepts of a quadratic. Without graphing, if you could factor it, you can find the x-intercepts. So the way that works is with factored form. So for example, let's say that I had, so just a quick example. Let's just say I had x plus 2 times x minus 3. All right, that's my quadratic function. It's a factored form of quadratic functions. All you have to do to find the x-intercepts is set both factors equal to 0 and solve them individually. So you would subtract 2, x is equal to negative 2. Add 3, x is equal to 3. So my x-intercepts would be at the points negative 2, 0, and 3, 0. So I don't expect you guys to do that necessarily right now, but it's a good thing to jot down because later on the unit you will have a whole lesson on this. All right, so it's just a good thing to kind of keep in the back of your mind. Also, if I ask you for the x-intercepts, I want it as the actual point unless stated otherwise. So you need to have it as the number of the x value, comma, 0 with parentheses around it. You want it as a point. Now, on top of x-intercepts, you have the y-intercept. Now, the y-intercept for any function, again, it's where it crosses the y-axis, but there is only one y-intercept. All right? So any function, there will always be only one y. X-intercepts can vary. Y-intercepts, there's only ever one y-intercept. There's never not a y-intercept. There's always going to be a y-intercept, but there's only going to be one. And you can find that using the standard form of the function. And the way we find that is, it's very similar to when we did y equals mx plus b. All right, remember that? That's a linear function. What was the y-intercept in y equals mx plus b? What value gave you that? So linear functions, what value, this is review, what value or what letter gave you the y-intercept for y equals mx plus b? That's slope-intercept form, by the way. All right, my little sleepyheads, come on, wake up. Up, 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 up. So, guys, this is review. Bread and butter of Math 1 is linear functions. What variable gives us the y-intercept? The b gives us our y-intercept. So, in other words, our constant gave us the y-intercept. When we have the standard form of a quadratic, y equals ax squared plus bx plus c, if the constant gives us the y-intercept of a linear function, guess what letter the y-intercept of the quadratic function will come from? Nope. C. So, your C value gives you your y-intercept. All right? And that's because it's the constant. That'll go for just about any function. Whatever the constant is, or whichever letter's not, or whichever number's not connected to a variable, that's typically your y-intercept. All right, so if I wrote this, y would equal the point 0 and then c. And that's how you want to write your y-intercept, as 0 and a number. Now, again, that's really nothing new for you guys. The only thing that's relatively new in this part is the fact that you have multiple x-intercepts and where you can find them within the function. Everything else in terms of finding them is pretty much the exact same. So let's look at the examples below. So they gave us this graph, example 1. They want us to find the x and y intercepts. So let's start with the y-intercept. So take a moment on your own, find the y-intercept. Just look at the graph, find the y-intercept. All right, let's go with Olivia. Where's the y-intercept on this graph? Right here at -6. So as a point, that would be what, Olivia? 0, -6. So that's where our y-intercept is. It's right here. All right. Now, let's find our x-intercepts. Now, before even starting, how many x-intercepts do you think you're going to have? 2. All right. All right, so let's go, Ben. Name me one of the x-intercepts. So where's one place that the graph crosses the x-axis? Yeah, it's at -2. You're right. So one of them is at the point -2, 0. Where's the other one, James? 3, 0. So both of these right here are the x-intercepts. Now, the next two examples, all right, we're going to find the x-intercepts and the y-intercept. So, first off, what form is that function in? Factored, standard, graph? What form is that in? So let's go, Ralph. What form do you think that function's in? It's in factored form. So this function is in factored form. Now, Ralph, what key feature can we find specifically from factored form? The x or the y-intercept? The x-intercepts. All right. So without even having to graph this, I'm going to find the x-intercepts. And the way I do that, take both of these factors, set them equal to 0 separately, and solve. So I subtract 8, x equals -8, add 3, x equals +3. So my x-intercepts are at the points -8, 0, and 3, 0. Now, my y-intercepts, or my y-intercept, sorry, I'm going to graph in Desmos to find. So take a minute and type this function in Desmos exactly as you see it. Just replace the f of x with y. So you should have y equals x plus 8 times x minus 3. So graph this function in Desmos exactly, replacing the f of x with y. So everyone should be graphing it in Desmos. So I should see everyone on their laptops graphing in Desmos. Thumbs up if you got graphed in Desmos. All right, another minute. Everyone needs to graph it because I'm not pulling up the graph, so you need to graph it. All right. So first off, can we confirm that we got the correct x-intercepts? Yes or no? So check where your graph crosses the x-axis. It should cross in 2 places. You should be able to click on those 2 points. So do they cross at -8, 0, and 3, 0? Is that true? Good. It should. Now, let's go with Lissandro. What's the y-intercept? Were you able to get it graphed?
No, I did the exit, but I think I won.
All right. So, help him out. Brian, what's the y-intercept? All right. So, guys, if you had issues graphing it, All right. You literally type it in exactly as you see it. So y equals parentheses x plus 8, close the parentheses, x minus 3, close the parentheses. You literally just type it in as you see it. And you might have to zoom out a bit. So we confirmed that these are x and y intercepts. Can someone tell me what the y-intercept is? Lysandra. Negative what?
30.
Not quite.
Oh, we're, -25.
It's negative 24. So that's why you need to graph it, because it's easier to click on it, because sometimes it's really hard to eyeball it. So 0, negative 24 is the y-intercept. Now, take a minute for this second one, graph it, tell me what they are. So take a minute, graph them on your own. I want to know what the x-intercept is and the y-intercept. So again, put it in exactly as you see it. As soon as we finish this. So graph it, find the x-intercept, find the y-intercept, and list them. Thumbs up if you're ready. Give you guys one more minute. So if you don't see one of the intercepts, zoom out, because it may just be higher up. All right. Check your answers. So you should have gotten 3 and 7 for your x-intercepts, 21 for your y. If you look, 21 was your constant. So you didn't even have to graph it to get your y-intercept. So if you did graph it, it would have looked something like this, and you could have clicked on all 3 points. Any questions on x and y intercepts? Those are probably the easiest to find. All right, so we're not done with notes for today, but y'all need to wake up. So we're gonna go ahead and take that 5-minute break. If you need to use the restroom, you need to stay on this hallway. You cannot go anywhere else. You can get water and you can use the restroom, but you cannot wander. You need to be back here in 5 minutes by the time this timer goes off. Mm-hmm. Yes. Hold on. Open. Huh? Is it? right, y'all. So, hope you guys, if you were sleepy, hope you guys got that 5-minute power nap. All right. Now, everyone should have their heads up, and we're getting back on it. So, moving on from X and Y intercepts to the next, which is vertex and axis of symmetry. Now, vertex and axis of symmetry is a key feature that is only for quadratic functions. So this is brand new to you guys. You didn't see it with linear, you didn't see it with exponential. It's something that's unique to only quadratic functions. So, but vertex and axis of symmetry kind of go hand in hand. So first off, what the vertex is that it's the minimum or the lowest or the maximum or highest point on a parabola. So the reason there's an or is that on a parabola, depending on its orientation, it's either going to have a minimum or a maximum, meaning it's going to have either a lowest point or a highest point, but there's really no in between. The vertex is also always written as a point. So your vertex is a flat out point. So you have to write it as a point x, y. All right. So it's either the highest or lowest point on the graph, depending on what the graph looks like. All right. And it may sound like it'll be complicated to find, but it's really not. Now, axis of symmetry goes along with vertex because it's a vertical line that passes through the vertex. So it goes through the vertex and cuts the parabola into two symmetrical pieces. All right. So what does it mean for something to be symmetrical? This, if you cut it in half and you like fold it over each other, it would be the same on each side. All right. So that's why I said here that you cut it in half, because it literally cuts the parabola in half vertically. Now, the axis of symmetry, which you'll probably see it as AOS a lot, it's written as an equation of a line. Now, review from last semester. It's a vertical line. How do you always write a vertical line? Something equals. So something equals a number, X or Y, for a vertical line. X. So you'll always write it as X is equal some number. And that number is always equal to the X value of the vertex. So whatever the X value of the vertex point is, that's also your axis of symmetry. All right, so if you find the vertex, the axis of symmetry is really easy to find because you already got it pretty much. All right. Now, the little figure below kind of gives you a good idea what's going on. So first off, just note that every parabola has exactly one vertex. There'll never be more than one vertex. Never more than one axis of symmetry. There's only one of each. So if your graph looks like a U, the vertex would be considered a minimum value. It's the lowest value on the graph. And the axis of symmetry is this line right here that cuts through that vertex. Now, if your graph looks like an upside down U, then it's a maximum value. It's the highest point on that graph. And again, the axis of symmetry is the line that cuts through it. So, if it's oriented like this, so if it's oriented like an upside down U, it's always going to be a maximum. If it's oriented like a U, it's always going to be a minimum. That's how it's always going to look. All right. So now let's look at figuring it out. So first things first, example 4. We're going to draw and state the vertex and the axis of symmetry. So just by looking at this graph, do you think the vertex is going to be a max or a min? Do you think it's going to be the highest point on the graph or the lowest point on the graph? It's the lowest, so it's going to be a minimum. So in this case, the vertex is going to equal a minimum. So we're looking for the lowest point on the graph. Look at your graph and find where the lowest point is. And the easiest way to look at that is look at your y values. Vertically, which one is the lowest? So which one's the furthest down? Whereas the smallest y value. Right here at -9. So if we look at -9, the vertex would be right here. So this point right here is the vertex. Someone else tell me what that point is specifically. -1 and -9. So the vertex is equal to the point -1, -9. That's our vertex. Now, the axis of symmetry is a vertical line that cuts through a vertex. So if we drew the axis of symmetry, if we're going through the vertex and it's just a vertical line, that means it has to go through here. So if I extend that line to fit my graph, this is what it will look like. All right. Now, I drew it as a straight line, but a lot of times it's also a dashed line. So you can either draw it straight or you can draw it as dashed because it is kind of a more invisible line. So this right here is my axis of symmetry, or my AOS. So just know that AOS stands for axis of symmetry. Now, remember, your axis of symmetry is written as x is equal some number. So when you write the axis of symmetry, you cannot just state what number it's at. You have to say x equals, because if you just give me a number, it's very vague. I don't know whether it's the y value that you're looking at, the x value, whatever. All right, so you have to be specific and say x equals whatever number. What is that number that it's equal to, Addie? So what x value does that line cut through? It's also the same x value as the vertex. So what's the x value of the vertex? The x value, -1. That's also the axis of symmetry. So the x value of the vertex is -1. Thus, the axis of symmetry is that x is equal to -1. So like I said, if you can find the vertex, you already have the axis of symmetry because it's just the x value of that point. Guys, heads up. Now, there's no special trick to finding the vertex from the function, purely from the function itself. Well, there is, but you need a different form for that, which we're not learning. That's where vertex form comes in. So for right now, if I ask you to find the vertex or axis of symmetry, you need to graph it. So go ahead, take a minute, and graph in Desmos example 5. And see if you can figure out what the vertex and the axis of symmetry is. So graph it in Desmos and state what the vertex and the axis of symmetry is. So remember, replace f of x with y equals. Or if you type f of x, it'll still work. So remember, your vertex will either be the lowest or highest point. So if it looks like a U, it's a lowest point. If it looks like an upside down U, it's the highest point. All right, so let's go with Taylor. Was the vertex the highest or lowest point on the graph in this case? So did it look like a U or did it look like an upside down U when you graphed it? It does look like a U. So would that be a maximum or a minimum? It's a minimum. So in this case, the vertex was a minimum. So we had a minimum vertex. Now, Taylor, what was the point for the vertex? All right, can someone help her out? What was the point for the vertex? 5, negative 23. So if you're looking at your graph, should it look something like this? All right, your vertex is your lowest point, which if you click on your graph, it actually kind of already highlights the point for you. So if you click on the graph, do you see how the point is already highlighted? The highlighted point that's not crossing the X or Y axis is actually your vertex. So if you click on that point, that is your vertex, which is 5, negative 23. So let's go Neely. What would be the axis of symmetry if that's our vertex? So it's always the X value of our vertex. So what is that? Right. So we would write this as X equals 5. So again, if you got your vertex, you got your axis of symmetry. So if they ever ask you to just find your axis of symmetry, you should still find your vertex because that'll give you the X value for your axis of symmetry. All right, guys, last one and then we're done. So graph this one and find the vertex and axis of symmetry. And everyone needs to graph it, please. So again, all my sleepyheads, graph that function. Tell me what the vertex and axis of symmetry is. And make sure you type that graph in exactly as you see it. All right, so let's go Kyrie. Would the vertex in this case be a maximum or a minimum? It's a maximum. And what was that vertex? It was 1, 2. Good. So your vertex was the point 1, 2, and it would have been the highest point on the graph, so it's a max. It looked like an upside down U. So let's go Caroline. What is the axis of symmetry then if that's the vertex? What's the x value of the vertex? 1. So the axis of symmetry in this case is x equals 1. So again, if you know the vertex, you got the axis of symmetry because it's the x value of the point. All right. Okay, we'll call it from here today. We'll finish the rest of it tomorrow. So you should be able to work through the delta math that I gave you, except for the last section of the delta math. So everything else you should be able to do. All right, so the last section of the delta math, just hold off on that until tomorrow. But besides that, you should be able to work through it. Oh, yeah. Okay, it should work now.